Well, we have another question here, question 4. The question says, given the exponential function g of x equal to ½ to the power of x. 4.1 says, write down the range of g. All right. What should be the range of g then? Now, when we look at this exponential function, okay, we need to understand that this exponential function, okay, when there is no a horizontal asymptote associated to it, the exponential function will always be positive, okay? Because the formula says that a to the x is always positive. Therefore, the range, which are the acceptable y values, are the y values that are positive, greater than 0. Okay, that was question 4.1. Now we're going to do question 4.2. The question says that determine the equation of g minus 1 in the form y equal to. I'm writing my question here, 4.2. So we're looking for g minus 1, okay? The equation of g minus 1 in the form y equal to. Well, we do know that g of x is given by ½ to the power of x, okay? So I prefer to write this way. G is like g of x is y, okay, equal to ½ to the power of x. Now, g minus 1 then is when we will reverse the variable. We're going to switch the variable. We're going to call a variable xy and then yx. So this becomes x equal to open brackets ½ to the power of y. Okay. Now, and because we're looking for y, I prefer to keep my known on the left, so I can write ½ to the power of y equal to x. Now, I think you know this property for logs and exponential function. The inverse of exponential functions are logs and vice versa. There is a property that says this: log of a base b equal x implies that b to the power of x equals to a. So in this, we can write, similarly, we can write b to the power x equal a, means this is like log of a base b equal x. So this is the same situation, okay? The base here is ½ now, and the exponent is y, x. So let me just write it even better. I prefer to write it this way. In class, that's x equal to log of a base b. Yes. So those are the formula. In red is the formula. So we can write our variable here is y, okay? Because ½ to the power of y, so b to the power of x. So it's gonna be x now. X equal to log x equal to, okay, x, this x here is y here because this is the exponent, okay? The exponent is y, so y equal to log of a base b, okay? A here is x, and then the base is ½. So it's like that. So y equal to log of x base ½. Someone else can also write this answer like, we can also write this answer like, you know, if you know the log properties, it's going to be like x 2 to the negative 1, which is also the negative of the exponent here must be here, negative log x base 2. Okay, but this one you can use this if you know the logs property, because we can rewrite the same like this, or else we can solve it like this. Let me show you how. Someone could transform here y was given in g of x. Y was given like a half to the power of x, right? So this can be written as y equal to 2 to the negative 1 to the power of x. If you remember the law of exponents, so you know the property that says a to the negative m is equal to a over m to the m. Remember, those laws are applied in both orders, left to right and right to left. So a half can be written as 2 to the negative 1. Now, this is the same thing as 2 to the negative x, because we're going to times the exponents here, negative 1 times x, according to this law of exponent that says a to the m all to the n equal to a to the m times n. Excuse me. So now, if you have this, then to work out the inverse, g minus 1, it's when, as we said, we're going to switch x by y, and then we're going to switch x and y. So this is going to make it like x equal to a half to the power of y. We can write like a half to the power of y. Actually, not a half, but 2 to the negative 1, I mean, because we call it 2 to the negative 1. So 2 to the negative x, I mean. Wait. We are here y equal to 2 to the negative x. So we can to work out the inverse, we're gonna say x equal to 2 to the negative y. So this is the inverse, okay? And then I prefer to write it like 2 to the negative y equal x, and then applying the law of logs that the property of logs that we wrote here in red, we can say that y will be equal to negative y, I mean, equal to log of x base 2, okay? And then y will be equal to negative log of x base 2. Okay, we don't really see it there. Let me just move my board a little bit up there. Okay. I'm gonna write it. I'm gonna write it because of space. I don't think I'm getting the space. I'm gonna write it over here. That makes log of x base negative. So y will be equal to negative log of x base 2. So you can use either, you can do this way or this other way. The two are the correct answer. Okay. So you can write this one or this one. C correct. Now the following question is question 4.3. The question says that is g-1 a function? Justify your answer. Well, you know, I will say yes, because the graph of the logs function can okay, let me do it here. Let me show you something. Okay, the graph of a log function is something like this. It's like this. Okay, in the Cartesian plane, if the Cartesian plane is like this, okay, log functions goes like this. Okay, that's log of x base a. Okay, but now because we have negative logs, it means our graph will rather be like that, and then this graph will pass the vertical line test. So meaning wherever we can draw a vertical line, okay, the vertical line here can cross this graph at exactly 1 point. So we can say the graph here is G, we can say that the inverse of G is also a function. So yes, it is a function. Okay, because the vertical line test cuts G minus 1 at exactly one place. Now, regardless of wherever I can draw it. Now, question 4.4, the question says that the point MA2 lies on G minus 1. Calculate the value of A. Okay. Let me just do it somewhere. I want to move my board. Let me do it somewhere over here. Okay. Yes. So over here we have like question 4.4.1. So we have like a point M. So we're looking for the value of A. Okay, we're looking for the value of A. And the question in the question here, it is said that the point M lies on G minus 1. So we need to find the value of A. M is the point A, excuse me, A2, and then this point, let's say, lies on G minus 1. Okay, on G minus 1. Now, how can we solve this? Okay, if it lies on G minus 1, it means the coordinates of the point M satisfies the equation of G minus 1. So I would say G minus 1, okay, is like, I don't need the ruler here. G minus 1 is like Y equal to negative log of X base 2. If I use this other other formula. Now, okay, let me first just write the first formula. So it's going to be like log of X base a half. So if we sub in the coordinates of M, because it lies in the equation, that will be 2 equal to log of X base a half. Okay, so this will be then according our formula here, this formula log of A base B equal X. So I'm gonna write here like this. Let me reverse it. So it'll be like log of X base a half equal to. So in this situation, this is going to be like B to the X equal A. B to the X equal A. So so it's going to be like a half to the power of 2 equal X, or X equals to a half to the power of 2. So this will be X equal to a half to the power of 2. Okay, which means X equal to a quarter. Or if I use the other formula rows, like Y equal to negative log of X base 2. Okay, we sub in the coordinate of M2. And then, okay, when we sub in the coordinate, that was A, right? A, I meant to write A here. A, okay. 2 equal to negative log of A. A base 2. So this will be, I prefer to keep the unknown on the left. So negative log A base 2 equal to 2. So if I move the negative sign over, that will become negative, actually, positive log A base 2 equals to negative 2. Now, this will mean that A equal to 2 to the power of negative 2, according to this formula. Okay. A would be B to the power of X, so A here. And then this makes A equal to 2 to the negative 2 is the same thing as 1 over 2 to the power of 2. And then 2 to the power of 2 is just 4. So A is equal to a quarter. A is E equal to a quota. Now, the following question is question 4.4.2. That was 4.4.1 and 4.4.2. The question says that M, the image of, no, M prime, the image of M lies on G. Write down the coordinates of M prime. Now, if you put like this. (4.4.2). So we're looking for the coordinate of M prime. M prime is the image of M that lies on G. And we're looking for the coordinate of M prime. Okay. Remember that G and G minus 1, obviously they are inverse functions, okay? And then with the inverse function, we'll switch the variables x with y. So because M, the point M, we did find that the point M has coordinates like A was a quota and then 2. Therefore, M prime will have coordinates 2 and a quota. So x becomes y. X become y, y become x. Okay. Here is the x coordinate, that the y coordinate, and that will be the x. It will reverse. Okay. Switch variables. So this is the x at the y coordinate. Next question is question 4.5. Okay. Question 4.5 says if h of x equal to g of x plus 3 equal to if h of x equal to g of x plus 3 plus 2, write down the coordinates of the image of M on H. Okay. I prefer to, I'm gonna move my board like this. And then that's question 4.5. Okay. We're looking for the coordinates of M prime, okay, on H of x, and then h of x is given by g of x plus 3 plus 2. Okay. Now, it is important to know, excuse me, the properties of functions here, of transformation of functions, especially for questions like this. Now, the number 3 that we see here, this is what we call the horizontal, will affect the graph. It will change the horizontal shift of the graph. Okay, it will shift it 3 units to the left. So we're going to minus 3 from M. M was given by M prime was given by 2 and a quota. That's when M prime was in G minus 1. So we're going to minus 3 units here because we plus 3 there. Okay, horizontal shift, we minus 3. When we see plus 3 here, the graph, the same graph of G, shift 3 units to the left, not to the right, careful, but to the left. So we're going to minus 2 over here. Then when we see another scalar here, number 2 plus 2 here, this is what you call the vertical shift in the same graph of G, shifted 2 units upward. So when upward is, we're going to add 2 there. Therefore, the new coordinate, the new point M prime will be 2 minus 3 is -1, and then a quota plus 2. You know, you have like a quota right here. A quota plus 2. Remember, 2 has a denominator of 1 here, so we need to make it a quota with a denominator of 4. I'm going to times by 4 here. times that by 4, and then this will become like a quarter plus 8/4, and then this is 9/4. So that's 9/4. This is the new M prime. Thank you.